So once again, very good afternoon and hello to everyone. And thank you for joining me in this session. So let's start the class. So my name is Abhishek Mishra and I am teaching you manufacturing here in GATE and ESE Quest channel. And in today's class, we will be continuing our discussion of important questions that can come or with respect to your GATE examination from the manufacturing subject itself. And before starting this class, let me just inform you that this class will entirely be in English, and this class will be I am taking mainly this class to share or provide you some important tips and tricks and just make you aware of some potential mistakes that you can make, that you can just be aware of, so you can just be well prepared if that confusions or doubts arise during your examination, and you can avoid them and just give the right answer. So I have secured All India rank of 662 in GATE 2020, that is this year's GATE examination, and I have completed my MTech in 2019 from IIT BHU Varanasi, and I have got a good teaching experience of 2 years in mechanical engineering subjects. Some of my interests are listed in the screen. They are editing, photo and video, cricket, football, and I like all sorts of games. So now I am going to discuss about the Unacademy subscription plans and why you should subscribe to Unacademy and how the Unacademy subscription might benefit you. So first of all, just go and download this app. This app is absolutely free of cost for you to download and check out. And in one line, this app is a complete package. In this app, you will find each and everything that is necessary for your GATE exam preparation. So if you can name one thing for your GATE exam preparation that you need, this app has got it covered. So just download it and check it out for free, and just and I think you will find it very beneficial for your GATE preparation. And remember, for online preparation, if you are doing preparation online for GATE examination, then remember that take advantage of each and every resources that you think can benefit you or that can benefit you, and this Unacademy's app is one of them. Now Unacademy subscription is just like any other educational services fee that you have to pay to receive that service. Here Unacademy is providing you the lot of quality content, and they are providing you this content with asking a reasonable price, and that reasonable price, after you have paid, you will be getting contents from day one. Daily, day in day out, you will be receiving new content. And also the content here, as I have mentioned before, is one of the top notch contents that you can find anywhere on the internet right now. So the benefits of Unacademy subscription are listed right here on the screen that you can see for yourself. Live classes will be held daily, so day in day out you will be you can attend live classes in which you can ask your doubt, answer polls all while the class is going on. So the level of interaction is far better than what you can see on YouTube. And live tests and quizzes are there for you to evaluate your preparation, and also analysis will be provided by Unacademy's team for you to do that. And structured courses are there. For example, if you are preparing for GATE examination, then you need the courses to be taught in such a manner, in such a order that they create a progressive they just create a progressive approach or a rhythm which is very beneficial, because for GATE examination you will be studying for a large number of days and you want yourself to be motivated and energized throughout your preparation. So the structured courses will help you in making you motivated and energized throughout your preparation. And unlimited access of content will be there. So if you are subscribing today, you will be getting content not only from the day onwards, you will also be getting content from the before that you have subscribed. And this content you can access at any time. So unlimited access is there for you to just take benefit of, do classes, attend classes that has already happened in the past, that you find uh, reasonable or not reasonable, that you find suiting to your needs. And Unacademy has hired a lot of top educators for you to study from, and these top educators will provide you a correct approach and a efficient and an effective path to just do your preparation, and they will share their experiences, tips and tricks. So overall, the experience accumulated by this top educators, the way of teaching, will ultimately benefit you, the viewer, you the student, the most. And Unacademy has also this option of studying from multiple educators which are available for a single subject. So you can just select an educator which you think resonates with you the most, and then just attend his or her class. Or if you're finding some parts of the one teacher or educator better than, and some parts not that up to your expectations, then you can just attend multiple educators for a simple single subject. And this is another thing, another benefit for you to take advantage of. So here are the new subscription prices, and these subscription prices are for the plus subscription type of plan that Unacademy is providing. And here you can see that the most discounted plans are 12, 18 and 24 months plan, and these plans are having 12 months plan is having 54% discount, 18 months 61% discount, 24 months 67% discount. So it's better that you choose from either of these plans if you can afford. And if you are preparing for GATE 21, then you should also have a look at 12 months plan, because then you have to prepare for your interviews and some other examination after the GATE examination. So this 12-month plan will make you will keep the resources available for 12 months at a very affordable prices. And these prices are, as you can compare with the traditional classes, they are very affordable. And they also include test series, which is absolute must for your GATE preparation. And therefore, if you see it like that way, these plans are absolute worth the money they are asking for. And you can just have no cost EMI available. You can have the no cost EMI payment option for 6 months and above subscription plans. And as I have mentioned before, plus is for classroom experience. So this is classroom type. And if you want 10% more code in any of these plans, 10% more discount in any of this plan, then you have to just enter this code ABHIMI to avail the discount of 10%. For example, if you are entering using this 10% code on 30, 20, 50, then your 10%, that is 3025 rupees, will be off if you use this code. So this is special code, and this is giving you extra discount other than the discount already provided by Unacademy's website. So just note it down and use it to avail this extra special discount. And you can only use this once, so just select one plan which you need, which you think is the most suitable for you, and then just go for it if you can afford it. And again, this code is universal for any subject, for any course, for any exam. This code can be used not only for GATE, and also multiple students can use the same code in multiple accounts. So in different accounts, different accounts can get this code used again and again. So you should also share this code with your students and friends, with other students and friends, so they can also get this benefit, because as I have said, not only you can use this code. Electricity went off and the OBS got disconnected, that is the streaming software. So now I have connected it with my mobile data, so I should be good to go for the duration of this class. So I think we will have now our uninterruptible session begin. So what we were discussing is that this code ABHIMI is there for you to get 10% off, and the best plans to choose from are 12 months, 18 months and 24 months plan, because these are the ones which are going to which are there with the most discount, so discounted prices. So these are the ones in which you can save the most. And after you have entered this code, the prices will be like this, which I have also shown here. So these discounted prices are there for you to just avail, or you to just get the subscription in, if you use this 10% off code ABHIMI. And again, the best plans 12 months, 18 months and 24 months plan, if you can see, the per month cost of these plans are very reasonable, because these are not only providing you the amount of content by the educators, with the top educators, but also providing you test series and their analysis, and the test series and all this content will be updated regularly. So daily live classes which will be held day in day out. So this Unacademy subscription plans of especially 12 and 18 and 24 months are worth the cost they are asking. And there is another plan which is Iconic, which is for those who need more assistance. So personalized test series, personalized coach, and again the prices are listed here. 10% off code can be applied also here, and that 10% code, if you can apply the new discounted prices of this Iconic subscription plan, is shown here. And these prices are again very much worth, because these are providing you personal coaches, personal assistants, personal test series to, so what, and you can also get this at by paying through no cost EMI, which is available on 6 months and above subscription plans. So Iconic will have this available. And finally, these are the benefits of Iconic and Plus listed in the screen. And 10% off code is also shown here in all capital letters ABHIMI. And also it is, you can see that the Iconic plan is having all the benefits of Plus, but there are some additional benefits, which is mainly due to the fact that you are getting personal coach. So that's it for the Unacademy subscription discussion that I just wanted to have with you. Now we will be discussing about our questions, important questions for today's class. So I hope you are watching this class live. I will be showing this code throughout the session, because again this code is very important, and you must be applying this code, you must be using this code, so that you can get the Unacademy subscription, which is very worth the price they are asking for, in an absolute least possible cost possible. So our first question for the day is a welding question, and here it is asking that, the question is asking that a resistance welder is rated at 50 kilovolt ampere. at 50% duty cycle. Secondary voltage is always constant at 25 volts. If a job requires 1500 ampere current, determine the maximum welding time in a total cycle time of 30 seconds. So we will first write what is given in the question, then we will discuss the question. This question right here I have taken from the GATE conventional previous year question paper. So this question came in GATE, but this came in the as 5 or 4 marks question. But when you do this question, you will find out that this question can very well come as a 2 marks question, because this question is not that long, but this question also has some nice concepts which has not been recently asked. So this question will be quite a good one to do, and therefore we are doing it right now in our class. So a resistance welder is rated at 50 kilowatt ampere. So it is given power, I should just write here rated, is given as 50 kilowatt, and volts is given as 25, which is again rated. And if a job requires 1500 amps current, so we will just write it down as I actual. So actual current which is required. So what is rated current or rated volt or rated power? So let me just discuss here, or let me just inform you about rated current. So rated current is the maximum current a machine can withstand. So that maximum current we will be calculating first, and then our duty cycle is 50%. For that it is given, and then we have to find the duty cycle for our actual current which is required by the job, and which is given as 1500 amperes. And after we have done that, we can find from that duty cycle the maximum welding time if the total cycle time is given, which is 30 seconds. So the actual current we have 1500 ampere, and duty cycle for this rated current is 50%. So we know that I square D is equal to constant. So I square D is equal to constant. This means that the product of current square into duty cycle is equal to constant. Therefore we have current actual, we want to find out actual duty cycle. We have rated duty cycle, that is duty cycle for rated parameters, and we have to find out now rated current. So rated current, we are finding it here. So IR, which is rated current, and let me also write what rated current is. It is the maximum current a machine can withstand. So that IR can be obtained simply by dividing power with voltage, that is PR VR. So that current we are getting as, let me just calculate it. So I think I don't have my calculator with me right now, which also happened in yesterday's class. So very sorry for the inconvenience. I will be back in just 10 seconds. So again, sorry for that. I think I don't have the calculator with me right now, so I will be doing that, the calculation in my mobile phone. So let's continue our discussion. So what we were discussing, so what will be the current here? It will be, so current will is coming out to be 50 kilowatt, that is 50 into 1000 divided by velocity, not velocity, volts, 25 volts, which is the rated voltage. So current is coming out, rated current is coming out as 2000 amperes, and we know now the actual current and we also know the rated current, and now we have to just find the duty cycle for the actual current. So I rated square D rated is equal to I actual square D actual. So from here, what is the rated current value? 2000, we will do its square, and 0.5, because 50% duty cycle is for the rated current and actual current value is 1500 square, and the actual value of duty cycle we are calculating by this equation now. So this will come out as 2000 square divided by 1500 square maximum welding time in total cycle time of 30 seconds. And to do that, we have to use this actual duty cycle, and this actual duty cycle main what it represents, we have to also know that. So let us just let me just so the duty cycle represents welding time divided by total time. So we have duty cycle, which is actual, and we also have total time, and from here we can calculate welding time. Since we are using the actual duty cycle, not rated duty cycle, therefore we will be getting maximum welding time. If we used the duty cycle which was rated, we then would not have got the maximum welding time. So for maximum welding time, we have to use the actual duty cycle, which is calculated by calculating or by using the actual current. And therefore, if we multiply actual duty cycle with the total time, then we will be getting this welding time, which is now maximum welding time, which will be equal to, so this maximum welding time will be equal to 0.889 into the 30 seconds. So it is coming out as 26.667 seconds. So this right here is the answer, and let me just summarize what we have studied here in a manner which is easily accessible to all the students who are watching it live right now and who will watch it after some time in the recorded form. So let me go through this question once more in very quick manner in under 30 seconds or 1 minute. So we were given as this rated current we have to calculate, and we did divided the rated power PR with the rated voltage, and after doing that we got the value of rated current as 2000 amperes. And then we know that I squared D is equal to constant. So from here we calculated the actual duty cycle, which came out as 0.8889 or 88.89 percentage. And after doing this, after calculating this duty cycle, we use this duty cycle to find out the welding time, because duty cycle is equal to welding time by total time. So total time given in the question, duty cycle actual we are using because we have to find the maximum welding time, and after doing this we can get our welding time, which was coming out as 26.667, and the unit is seconds. So that's it for this question. Again, we will see now what we can learn more, if we can learn more from this question or not. So what we can get from this question of other than just doing this question, solving this question properly, is we can just know what a rated current is. So the rated current is the maximum current which a machine can withstand, and this current was provided to us in the question, and we have to use the value of this current and the duty cycle of this rated current for this rated current to calculate the actual duty cycle, and which is for the actual current, which is also already given in the question. And we can also learn from here that duty cycle, we have to use the actual duty cycle to calculate maximum welding time, because that is the one which will give us that if we are using the rated duty cycle, then we are not getting the maximum welding time. So let's do our next question. So during orthogonal turning of a steel by zero rake tool at feed 0.25 mm per revolution, depth of cut is determine the yield shear strength of work material under the given conditions. So again, this question is from GATE conventional papers, and this question is again one of the questions which will not only make you revise, go through all your machining formulas, but it is also an important question because of the amount of thing we can just do in this question, or we have to do to get to the answer. So let us just do this question during orthogonal turning. So first it is given that orthogonal turning, this means that approach angle is equal to 90 degrees. So that is what orthogonal turning means. Orthogonal turning assumption is that we have to make sure that we are taking the approach angle 90 degrees, and rake angle is given as 0 degrees, feed is given as 0.25 mm per revolution. So while we are doing this question, just keep seeing what the units of the values or the units of the parameters given in the question are. For example, feeds unit is always in mm per revolution, and axial feed unit is in mm per minutes. So keep track of that. And observations were made, and also the depth of cut is given, which is 2 millimeters. Tangential cutting force, which is F. So now another important thing, since this is orthogonal turning, so we are not provided directly with cutting force and your thrust force. We are provided with tangential cutting force and axial component of the cutting force. For orthogonal turning, remember that this tangential force Fz, which is given as 1000 Newton, this is equal to your cutting force, and the axial component of force, that is 500 Newton, this represents your thrust force. So you have to remember this thing and don't get confused. The tangential component of force is equal to the cutting force, that is Fc, when orthogonal turning questions are given or orthogonal turning discussion is being held, and axial component of that cutting force in orthogonal turning is equal to the thrust force Ft. So chip thickness is given now. So chip thickness is given as what chip thickness is given as TC1 mm. So this chip thickness is 1 mm, and with the help of diagram we have to calculate the yield strength of the work material under given conditions. Yield shear strength we have to calculate, and we will be calculating this in megapascals. So this class is not watched live by anybody right now, but if I recommend you to watch the classes live, because you can do the question along with me, and I will also provide you when I am discussing, so that you can give the answer to this question, and I will give you the amount of time which is optimum, so that you can have an idea of that also. So try to attend the classes live if you can, and I will be going live around 2 p.m. So keep track of that, keep note of that, subscribe to this channel, and hit the bell icon so that you can get notified whenever a teacher or an educator goes live. So, and also you can follow me in the Unacademy's website. There I am just taking the classes, this classes again, and I am doing that with better interaction there because of the tools provided by Unacademy in their website, which are very beneficial and which are very convenient for a educator and also for a student. So make sure you are following me there. You can follow me by just visiting their website and typing my name, which you can see in the title of this video. So let's just calculate the shear strength here. So for shear strength, we have to first of all find the shear force, and after finding the shear force, what we will do is we will first of all find the shear force, then we will divide this shear force with the so after finding this shear force, we will simply divide it by the shear plane area, which is area of cut divided by the sine phi angle, sine phi value. So this is how we can calculate the shear strength, and therefore we have to calculate phi for that. And for shear force, we can calculate it using this formula which we have obtained from the merchant circle, which is R cos beta minus phi alpha plus phi. So this is what we can do to just find out our Fs, which is shear force. So let's see how this r cos beta minus alpha plus phi is making us get the shear force. So for that we have to just draw the merchant circle, and we will only draw the merchant circle diagram till, or not fully, all the only draw the things which we need to calculate the Fs. So this is your tool, and this is your rake angle, and we have to extend it first so we can get the F. Then here is N, so frictional force F and the reaction force N. And here is the resultant R, and we also have this so I think this is a little bit of there is a little bit of problem by making the circle first, so we will just remove the circle here and draw this. So this is your FC cutting force, FT thrust force, resultant R. This right here is N. This is frictional force F. So this angle is beta, which is the frictional angle. This will be beta minus alpha. How? Let's see. So we will have this vertical line here. And we have this tool here. So this is our tool, single point cutting tool. And this right here is the angle alpha. This right here is the angle alpha, that is the rake angle, and oppositely this will be equal to this here. So this is 90 degree, so this will be 90 minus beta, and this is alpha. So finally we will get this as beta minus alpha. So this is alpha, and this is 90 minus beta. So if we will just add them, beta minus alpha plus 90 minus beta plus alpha, then we will see that we are getting 90-degree, which should be the case, and therefore that angle is beta minus alpha. I hope that is clear to you. Now we will draw the Fs, that is shear force, which is like this. So this is the shear force Fs, and this angle is phi, and this here right is the normal force on the shear plane Fn. So you will see that Fs is equal to R cos beta minus alpha plus phi. It is quite clear. And this all the figure, you can draw a circle around it so that it can become a merchant circle, but we just don't usually require to draw the circle when we solve this roughly. So you don't have to draw that when you are doing rough work. Just remember this figure, and from this figure we can learn a lot of things. But right now what we are needing is Fs calculation. For that we need this formula R cos, and the angle is beta minus alpha plus phi. So this will give us Fs, and therefore what the Fs value will be, let us see here. So Fs is coming out as, what will be the R value? R is the resultant, and R is equal to, so R is equal to under root of cutting force plus thrust force, which for this case is tangential component of cutting force and axial component of cutting force. So Fc is 1000, and Ft is 500. So the answer is coming out as, so let me just use the calculator here, which is the GATE's official calculator. So Fc is given as 1000 and Ft is given as 500. So we are going to calculate that right now. So 1000 square plus 500 square and root over the answer, it is coming out as, R is coming out as, resultant is coming out as 1118.03 newtons. So this value multiply by the cos of beta minus alpha plus phi. So we now have to calculate phi also and beta minus alpha also. So let's do that. Let's calculate these values. So here I am making the calculations. So R came out as Fc square. So let me write it here. The resultant R was under root of Fc square plus ft square, and it came out as 1118.03 newtons. And now we are going to calculate phi, which is obtained using this formula, which, as I have mentioned you before, very important formula. Just remember this formula every time you do a question. Make sure that you are, or every time you are studying the manufacturing notes, make sure that you are revising this formula. This formula is very important. Every time one or weight question usually comes from this formula usage. And therefore we have R now. So what will be the value of R, which is the chip thickness ratio? So chip thickness ratio, for that we have depth of cut and chip thickness 1 mm. So we also have feed rate. So for orthogonal cutting, feed rate is equal to your uncut chip thickness. So for orthogonal cutting, T will be equal to F. So from that we can have our ratio, which will come out as 0.25. Since in ortho gonal turning uncut chip thickness is equal to feed, and the feed was given as 0.25 mm per revolution. So from there we can just simply make the calculation, or calculate the, or simply know the value of small t, which is the uncut chip thickness. So we know alpha, it is 0, so this term will become 1, this term will become 0. So our phi from here is coming out as, phi is coming out as tan inverse of R, so tan inverse of 0.25 So let's use the official gate calculator right here. So we have to find 0.25 tan inverse, so it will be 14.036. so phi is 14.04. let's take, after rounding off, it is in degrees. Now we have to find beta minus alpha, and we know that tan beta minus alpha is Ft thrust force divided by Fc. So from here beta minus alpha is coming out as Ft minus Ft divided by Fc is 0.5, because we are given 1000 Fc and 500 Ft. So 0.5 tan inverse we have to calculate. After that we can find the beta minus alpha from that. So 0.5 tan inverse, it is coming out as 26.56. So beta minus alpha is 26.56 degrees. So we know now the beta minus alpha and phi. So now we can have this fs value known to us. It will be r cos beta minus alpha plus phi, and r is 1118.03. So let us just do that. 1118.03 into cos of 26.56 plus 14.03. So 14.04 it was. So let's just make the changes there. So it will be coming out nearly that, because 14.03 is not that of a change. So we will do the cos here. So the answer is coming out as 849.01. So fs is 849, let's take it that, newtons. And now to calculate shear strength, what we have to do here is we have to divide this fs with shear plane area, which is area of cut divided by sine phi. So our answer will be coming out as area of cut will be bt or fd. So f is given as 0.25 and depth of cut is given as 2. So that will be the area, and we have to divide it by the sine phi, and sine phi is sine of 14.04. So that is 2.06. So fs is 849. So this is nothing but fd, or we can also take bt, but we are going to take this because depth of cut is given and feed is also given, and phi is 14.04. So we have to divide 849 with this 2.061. So our answer is coming out as 411.93 megapascals, because f and d were in mm and fs was in newtons. So 411.93 megapascals. So this is the value of the answer that we wanted to calculate in this question. And you can see this question is quite on the lengthy sides of the question, or lengthy side, and therefore because it was a conventional question, but we learned a lot from this question. We learned how to calculate the shear strength, and for that we learned how to calculate fs because that was needed. Area of cut we learned here, if you can see properly, that it is either equal to fd or bt in orthogonal cutting especially, or in any, or if it was also not orthogonal turning, then also we are going to take fd and bt only for area of cut, because that is what the formula of area of cut is. Sine phi, for that we needed phi, and phi we calculated by using this formula. Tan phi is equal to r cos alpha divided by 1 minus r sine alpha, which again was a very important formula for you to remember, and you should be remembering this formula, as this is the most important formula in all of manufacturing and one of the most important formula in mechanical engineering for GATE examinations. And this formula is the importance of this formula can be just known by knowing this, or by the fact that each question or one or two questions every year or so comes which uses this formula in one way or another. And again we had r there. To calculate r, we didn't had the uncut chip thickness, but we had the cut chip thickness. For uncut chip thickness we use that assumption, or that we use the orthogonal turnings information or detail, that for uncut chip thickness will be equal to feed in orthogonal turning case, because it is equal to f sine lambda, and here for orthogonal turning the approach angle is 90 degrees, so t will come out simply as f, which is given as 0.25 mm per revolution. And we then calculated phi, and to calculate beta minus alpha we use another important formula, tan beta minus alpha, which came out to be ft divided by fc, and beta minus alpha now after calculating this came out to be 26.56. But we didn't know first what ft and fc were, that is what thrust force and what cutting force or force of cut was. But we know tangential components of cutting force and axial component of cutting force, and the tangential component of cutting force in the orthogonal turning case is equal to the cutting force, and the axial component is equal to the thrust force. So after doing that we calculated resultant from that also, and we also calculated beta minus alpha value from using ft and fc. And these are the things that we discussed, and we also discussed this merchant circle and the three set of forces with all the angles that are important for our calculation or for all gate examination. If you know this figure, you can do most of the questions in this topic by using this diagram and this figure and the formulas that you can just take out from this figure. So I think that will be it for this question. Again, this question you can just write it down in your copy so that you can revise this question one more time, and this will surely make you revise all the formula, make you use all the formulas, and after doing this question you can be just certain that you can be just well prepared, and therefore you can be confident that after doing this question your this topic will be better covered. And I think if you do this type of question, 2 or 3 this type of questions, you will be having all your doubts cleared in this topic, and your this topic will not require some further learning. Therefore all the questions that I have taught in this topic, particularly merchant circle, just do them. And I am making you these questions by not remembering any of the derived formula. We are doing this by just drawing the merchant circle, because by doing this you are not going to make mistakes, because you are seeing the figure and then doing the question. B, you are not going to remember all the lengthy formulas that we use to calculate forces. That is not required. You will just find it tiresome when you are going to remember the lengthy formulas, and also you will find that errors can be made because the formulas are quite confusing if you read them one after another. So you have to just remember a trick to do that. But it is better if you don't read the formulas, just use this merchant circle figure to calculate any forces or any angle that is asked to you. And you can do this very easily, and you can do almost any question from this merchant circle topic or from this single point cutting tool machining topic by seeing this figure only. So that's it for the question. Now we will do our next question right now. So let us just first of all erase this. So let's do our next question. And let me just write here what the answer to this question was. So the answer to this question was shear strength was coming out as 411 megapascals. It was coming around 411 megapascals. So you can just have this answer and do the calculation and find this correct answer after that. So our next question is also from the orthogonal cutting topic, and this question we will be doing very quickly because we have discussed our previous question in quite a detail. So we are now well versed in the, I think you are now well versed in the orthogonal cutting topic, so you will not have that much difficulty. But this question is also asking some little bit of different things, so it is good that we are going to do this question now. So before doing this question, the code is given at the top of the screen. 10% of code is capital letters ABHIMI, and this code is there for you to use when you are paying for an Unacademy subscription, so that you can get an extra discount of 10%, which will be quite a lot when you select 12 months, 18 or 24 months plan. So just choose according to your budget and just start your preparation, and don't forget to use this code to save 10%. So in orthogonal cutting test, the following data were obtained. Uncut chip thickness 0.25 millimeters. So let me just write what is given in the question. That's why I don't like this PowerPoint software, because what happens is that in this PowerPoint software, when you make a mistake or when you write something which you didn't intend to, or if you want to just do something undo, no option is provided for the users who are using a pen, a digital pen. So what you have to do is you have to just go here and then erase this. But in this software, which is Sketchbook by Autodesk, that option is provided, and a lot of tools is also provided. So I find this better to just discuss questions because of the things that are available here, and that is one thing that I just want the Microsoft team to do, is to make PowerPoint more what you can say suitable or more attractive towards or to the teachers, so that they can have all their discussion using this tool only, this software only. So uncut chip thickness, that is T, it is given as 0.25 millimeters. Cutting speed small v is given as 60 meter per minute. Tool rake angle is given as 0 degrees, and chip thickness TC is 0.75. Just observe from the data provided till now that we have written here, that always whenever you will see the chip thickness and the uncut chip thickness, you will find that the chip thickness which is after cutting is more than the uncut chip thickness. So the thickness will be expanded. This is happening due to the frictions and all that which chip is encountering after it has been removed. or during its removal, and the cutting force is given as 900 with thrust force as 450 newtons. So I hope you have gone through the question, and if you are watching this in a recorded session, just make sure that you are ready with the answer, because ample time has been provided when I was writing this given section. So these things were given. Now we will just calculate shear angle. We have to first calculate shear angle. So let us write A. Shear angle will be calculated by using this formula. And here R is the uncut chip thickness, or sorry, chip thickness ratio. So chip thickness ratio will be equal to uncut chip thickness divided by the TC, which is the cut chip thickness, and it was coming out as 25 by 75, so 1 by 3. So R is coming out as 1 by 3, that is 0.34, and alpha is 0, so tan phi will become then, so this is 1, this is 0, because alpha is given as 0 degrees. So phi we will get from here as tan inverse of R, so tan inverse of 1 by 3 or tan inverse of 0.344. So it is coming out as 18.435. So we will just write it till 2 decimal places. So 18.43 degrees. So this is your phi value, and it was simply tan inverse of 1 by 3. So this is our first answer. And secondly, we are being asked that in the B part of the question, that what is total power. So we will just write power. So what is power in making the cut? So power will be FC VC, that is cutting force into FC into V, cutting force into the velocity V, which is the cutting velocity. So FC is 900 and cutting velocity or cutting speed is 60 meter per minute, but we have to convert that into meter per second. So it will be 1 meter per second, and again FC was 900, so it will come out as 900 watts. And in the last part of the question, we were being asked the coefficient of friction between the chip tool interface. So coefficient of friction mu will be calculated by this. Mu is equal to tan of beta, and beta we have to calculate. So how we can calculate beta? We know a formula which I always stressed out the importance of. So that formula is, let me just write it down here. The formula is Ft thrust force divided by Fc is equal to tangent of beta minus alpha. And where this formula is coming from, let me also show you that. So it is coming from this merchant circle here. Just see this beta minus alpha and this triangle which is being made by Fc, Ft and beta minus alpha angle, and R this resultant force. So it will be Ft divided by Fc will be tangent of beta minus alpha, tangent of perpendicular by base. So therefore this is coming from, and from here we can easily calculate beta minus alpha. So beta minus alpha will be Ft divided by Fc, and Ft is and Ft is 450 and Fc is 900. So 0.5 tan inverse will be beta minus alpha. So Ft divided by Fc, it is 900, it is 450. Therefore 0.5 will be equal to tangent of beta minus alpha. So beta minus alpha will be coming out as tan inverse of half. So it is 26.56 and the alpha was, rake angle was given as 0 degrees. So this is your beta, and we have to just find the tangent of this to get the coefficient of friction. So the tangent of this will be 0.5 only, because 0.5 tan inverse was 26.56 and tan of 26.56 is 0.5. So this is your coefficient of friction. So again you can see how properly we have done this, how by using how much less of pre-required formula we have done this. We have only we only need the formula, that is r cos alpha divided by 1 minus r sin alpha, to calculate phi, and from there we can easily find out this power, which is again Fc by V, because we know power is simply cutting force into cutting velocity or cutting speed. And mu we also calculated after finding tan beta. We didn't require any tan beta formula because we used the merchant circle to do that. And if you can remember the formula, this formula, that is if you can remember this very important formula, tan of beta minus alpha is equal to Ft thrust force divided by Fc cutting force. Then you can solve a lot of questions, because after this formula that is tan phi is equal to that is formula to calculate the shear angle. So after this formula, this tan beta minus alpha is equal to Ft divided by Fc formula is the most important formula, because we are seeing the amount of questions that are being asked using this formula in not only GATE examination but ESE and some other examinations are very good in number, in amount. So to make sure that you are not wasting your time, just remember this formula, that is tan beta minus alpha is equal to Ft divided by Fc, where Ft is thrust force and Fc is cutting force. And usually remember that Ft is less than Fc. So that's it for this question that we have discussed. We can just learn from here little bit things also, new things also, or you can say little bit of things to take away from this question is in orthogonal turning. First of all, in any cutting operation, we usually found the chip thickness to be greater than the uncut chip thickness, and this is due to the friction, and this is due to the friction and the temperature increase, the expansion is there. And also we will get the information from here that two formulas are there for us to just properly remember each and every time. That two formulas are tan phi formula to calculate the phi angle, and tan beta minus alpha formula to calculate that tan beta minus alpha value. So these three angles can be found there, and usually alpha is given, that is rake angle is given. So we can find all these three angles by using these two formulas. And remember that if you are being given the line that use Merchant's theory, then don't use the Merchant theory before you are sure, or if just first of all calculate the angles using these formulas that I have discussed. And if you can't find the formulas by any other way, you cannot find the formulas by using Merchant circle, simply just remember this, then just use the Merchant's theory. So Merchant's theory should always be used when you are sure that you cannot find the angles by any other way. If you can find by the angles by any other way, if all the doors are not closed to calculate the angles, then do that calculation and find the angle, because else your answer will be wrong if you directly use the Merchant's theory to calculate the angles. So now we will do our next question here. So for today's class, let us see how much questions are left. So 4 questions are left for today's class. So let us do 4 questions one by one. We have done 1, 2, 3 questions we are done, but the questions were all conventional questions. Therefore, we took our time so that we have a proper understanding of all these questions. So let us do these questions. After doing this question, we will take a very short break of 5 minutes or so. So this question will take, I think, 10 minutes. And after that, we will discuss. First of all, we will make sure that we are discussing this question very well, because this question only we have to find this, use the one formula to calculate the answer to this question, but we will make sure that we are doing that properly. And also after that, we will be taking a little bit of break, 5 minutes, and we will then continue our 3 questions that are left for the day. So let us do the questions now. So in this question, it is asked that determine the Merchant's constant C, shear angle relation. And we have to do that for aluminium from the following orthogonal machining data. And the data is rake angle 35 degrees, that is alpha given to us. Uncut chip thickness T is so again the electricity went off, and therefore we face this problem, but we are now connected. So I will be making sure that this electricity problem has been dealt with in a matter of a few days. So let's continue our class, let's continue our discussion. So we calculated this value and we will take the tan inverse of this, and then we can find the value of phi, which is coming out as 29.87. So phi is coming out as 29.87 degrees. So this is the value of shear angle that we calculated. Now what we have to find is we have to find the angle beta, that is frictional angle, and in the question there is nowhere to be seen coefficient of friction. So what we have to do is we have to use this another formula that I just pointed out, that I just recommended you to just remember, that is tan beta minus alpha is ft divided by fc. From here beta minus alpha is going to be, ft is given as 90 and it is 200 fc. So 90 divided by 200, tan inverse of this is beta minus alpha, it is 24.22. So this 24.22, or we can take 23, we have to just put here and find the answer. So we have this beta minus alpha with us, which is 24.23. we have this phi with us, which is nothing but 29.87, which we have calculated using this tan phi formula, and we will multiply it with 2 and then we will do our calculation to get the answer. So the answer, that is Merchant's constant, that is 2 phi plus beta minus alpha, it is coming out as plus 2 times 29.87. So it is coming out as 83.96 degrees. So this is the value of your Merchant's constant. So Merchant constant is 83.97 degrees by taking the round off. So this is the value, and again from this question you can just take this information home, that Merchant circle, or you are already in home, so just take this information and remember that Merchant's constant C is, so let me just provide you the necessary things that you have to remember here. So Merchant's constant C is equal to 2 times of shear angle plus beta minus alpha, and that shear angle phi can be calculated from this formula, and beta minus alpha can be calculated from this formula, which all are already known to you as we have discussed them in detail. So we got our answer C as 83.97 degrees. So therefore this is the thing that you have to remember when you are doing this question to calculate Merchant circle. And this question again was asked in GATE conventional, which was held 20 to 30 years before, and this question was of 4 or 5 marks. It should be of 4 marks, but the calculations involved but the main answer calculation involved calculating beta minus alpha and phi, so there are quite a few steps. So 2 marks question will be asked from this question, and it is possible that GATE asked this question because first of all the pattern which is followed by the GATE examination in recent years, that is 18, 19 and 20, is lengthy questions which are providing a lot of data or sometimes extra data which are not needed, and that questions are easy. So this question again is easy. We have to just know the merchant's constant formula and use the data provided to us to solve this question. And therefore just remember what the formula is, and make sure that you do this question properly so that you are well prepared in this orthogonal turning or machining, normally machining section of the syllabus. So let us just see if we can learn anything else from this question or not. So constant C is also here stated it as it is also stated it as a shear angle relation. So merchant constant, we will have the three angles related to us. It is 2 phi plus beta minus alpha. So orthogonal machining is provided in this question. The name of the machining is orthogonal machining. So here approach angle is 90 degrees, rake angle 35 degrees, and uncut chip thickness 0.15 mm. So average chip thickness is given, which is 0.3 mm. So here you can just remember that whenever you are taking the chip thickness in the formula of R, which is the chip thickness ratio, you are taking the average chip thickness. It is TC is average chip thickness. So it is not highest or lowest, it is the average value of chip thickness that we encounter during machining, and rest of the things are just simply data. So that's it for the question right here. Now we will take a little break of 5 minutes, then we will continue our question though. So the three questions that are left for the day are this one, which is also from the machining section, and it is asking to calculate material removal rate and specific cutting pressure. And then we will have this question which is having the ASA specifications of tool given and surface finish among these two tools, which is having better surface finish, is asked. And next we will have this question from the metrology section, which this type of question you can just see it came in previous year GATE also, this type of question. So here simply we have to find out the relation first of all between the three terms here, and then we have to find out what is asked in the next section of the question. Let me just make it clearly here. This is H and this is D alpha. So we will be back after a 5-minute break, so let's take that break now. So welcome back everyone to the class. Let's continue our three questions that were left for the day, and let's do them in a very detailed manner, discuss them very detailed manner, and also discuss along the way tips and tricks that we can get from that question. And also we will analyze that question like we are doing for previous. So here, first of all, the top side of your screen or the top position of your screen has this code which will give you 10% off when you go to Unacademy's website and subscribe to their website so that you can get the contents there. And there I am taking manufacturing classes also, but I am having a better interaction with you. I can have a better interaction with you there. I can just provide you the questions there and you can answer them just like you do in your GATE examination by choosing the options A, B, C for objective type questions. And you can also have this notes available to you, this PDFs available to you to revise when you attend the classes there. So just remember to use this code to subscribe and follow me at the Unacademy's website, in the Unacademy's website, so that you can get notified whenever I go live. Unacademy's mobile app is free to download, so just download it and just use it. Just check out the app, what the features it has and how it can help you in the online preparation for your GATE examination. So let's do this question first. So let's do our solution from here only. So we have to calculate material removal rate and also specific cutting pressure. So these are the two things we have to calculate for this question. Again, these questions are from the conventional GATE papers. So you will find that these questions are generally on the lengthier sides of the question, but this question might get asked in the GATE examination because GATE examination is asking some lengthy questions right now, but these questions are easy if you follow the basic concepts that have been taught to you or that are there in your notes. So to calculate material removal rate here, this is cutting. So usually while looking at this, we can just see that this is a turning process. So for turning process, the material removal rate is calculated by using this formula. We have discussed in one of our class multiple formulas to calculate the material removal rate, and the material removal rate here can be calculated by using this formula, which is F T velocity into 1000, and we will be getting material removal rate in mm cube divided by minute. So our answer here will come out as feed is 0.8 in mm. Remember, when you calculate material removal rate, you write the unit of feed in mm, and depth of cut is 1.6, again in mm, and the velocity cutting speed is 5.5 in meter per minute, but we will make this into mm when we are multiplying this 1000. So material removal rate will be coming out as 0.8 into 1.6 into 5.5 into 1000. So it is coming out as 7040 mm cube per minute. So this is our first part's answer, which is the material removal rate. Now we are being asked what is the specific cutting pressure is. So it is nothing but specific energy consumption, which is joule per mm cube. Just let it, we will write it properly so that you don't get confused. The power is in joule per second. The material removal rate is in mm cube per second. We will take and we will find that our specific energy consumption is coming out in joule per mm cube. So E, that is specific energy consumption or specific cutting pressure, in this case will be power 0.67 kilowatt. So it will be 670 divided by 7040. So our answer will be but this is in, remember that this is in we wrote here mm cube per second, but this was in mm cube per minute, so we have to divide 60 also, which we had to multiply here. So it is coming out as 5.71 joules per mm cube. So this is the answer of the second part of the question which was asked to us. So the answer to second part of the question which was asked to us is simply we can calculate it after dividing the power with the material removal rate. So power divided by material removal rate is giving us this specific energy consumption, which is nothing but specific cutting pressure, which is asked in the question. So what we did here is, let me just go through it again. We have to calculate material removal rate and specific cutting pressure for the following cutting condition. So to calculate material removal rate, we use the formula FdV into 1000, because that formula is used because all the FdVs are given, and then we have to find the specific cutting pressure. So for that we have to find the specific energy consumption, because they both are one and another, and we have to do that by dividing the power by material removal rate, because we have to get the units joule per mm cubed. Therefore we have to put the material removal rate in mm cube per second, and therefore make sure that you are calculating this specific energy consumption or specific cutting pressure by dividing 670, that is your power in watts or in joule per second, by material removal rate in mm cube per second. So material removal rate in mm cube per second, it is very important that you divide the 60 there with the material removal rate, so that the minute gets converted into seconds. If you are not doing that, then you are making the calculations wrong and you are doing this easy silly mistakes. So now we will go through what is given. Work material is given as steel. Ultimate tensile strength is given as 980 megapascal. So this is not of any relevance to us for this question. Tool material is high speed steel. Again, nothing that we can do for this question here. Depth of cut is given, feed is given, and always put the unit of feed as 0.8 mm only when you use the formula FdV into 1000. Cutting speed is always given in meter per minute, not always, usually given, so you have to convert that into mm to find the material removal rate in mm cube per minute. And power consumption here is simply given in kilowatt, so we are doing that conversion to doing the values conversion to watt to get the answer. So now I am going to write in the screen the material removal rate formulas, different formulas that I've already discussed about in one of my previous class, but for the new students, for the new watchers, let's do that once again. So for machining, material removal rate, first of all, it is equal to FdV into 1000 mm cube per minute, and this F is in mm, this is in mm, this is in meter per minute, therefore the 1000, and this is for turning. MRR is equal to, the next formula we have is FDLN, where F again is in mm, feed, depth of cut mm, length mm, and N is strokes per minute. So our unit will be here mm cube per minute, and this is for shaping / planning or planing. Now another material removal rate formula is, it is equal to power divided by specific energy consumption. So power is in joules per second, specific energy consumptions is in joule per mm cube. So our unit here we can get mm cube per second. So this is another formula which can be used to calculate the material removal rate. And one more formula is there which is used for drilling, or we can also use that for general purpose. That is area of cut into Fn, that is axial speed. It is in mm per minute unit, it is in mm square unit. So our answer is coming out as mm cube per minute. And area of cut, you can see area of cut for turning is F into D, or you can also find the area of cut, you can also find the area of cut as B into T, but we have used FD here, so that is nothing but area of cut, and V is in the units of Fn, that is axial speed. So that is the thing that you can just look into, so that you can have a better understanding how these formulas are related. And I have shown you four different formulas to calculate material removal rate for machining processes, and you can use the formulas according to what is asked, according to data that is given provided to you. And you can also use this formula to calculate things other than material removal rate that is provided here in the or that is shown here in the equation. For examples, you can calculate power by using the third equation. Specific energy can also be calculated using the third equation if MRR is provided, and things like that you can just do. So just note it down in your copy in one page or in one region, so you can just see what are the material removal rate formulas are in one place, so that you can have a better understanding and better knowledge about this. So now let's do our next question, which is from the machining topic. And this question is asking us that identical straight turning operation was carried out using two tools, and the two tool specification is given, tool 1 specification and tool 2 specification, and the ASA specification is given for same feed. So same feed of tool, that is feed is to be taken as constant. The tool which gives better surface finish, or feed, we should write it should be taken as same, not constant, because there are two tools. So same feed, so F is same, which gives better surface finish. So peak to valley height for surface roughness, so surface roughness is given by F divided by 8 F square divided by 8R, or F can also be given by, H can also be given by F by tan of side cutting edge angle plus cot of end cutting edge angle. So these are the two equations which gives us the value of this peak to valley height for surface roughness, or surface roughness value is given by this. Whichever tools will provide us least value of H will be the better surface finish providing tool. And here we use this when R is provided. When R is equal to 0, we use this second form of the equation. So just make sure that you remember this, both the two formulas here that is shown, and use the formula which is just according to this R, which if R is given some value, then use the first formula, because that is considering the R, that is nose radius. But if it is not given, nose radius is not given, or if it is given as 0, then use the second formula which is there when R is equal to 0, or when R is not being provided. So that is it. Now we will use our calculation. So simply what we will have to do is, let me just remove all the things, because now we are going to discuss one more important thing in detail. So H is equal to so we are using this as R is equal to 0, and first we will write the ASA specifications format. So it is alpha B, back rake angle, side rake angle, end relief angle, side relief angle, end cutting edge angle, side cutting edge angle, then R. that is nose radius. And from comparing the ASA specification, we can get that for tool 1, and here let's write tool 2. So for tool 1, end cutting edge angle CA is 5, here CA is 7 in degrees, and side cutting edge angle is 25 for this, and here it is 30 degrees. So H1 will be F, same, tan of side cutting edge angle plus cot of end cutting edge angle. So tan of 5 plus cot of, tan of 25 plus cot of 5. So what it will be? So it will be 25 tangent plus 1 by 5 tangent. So it is coming out as 11.89, and we have to make sure that we took the reciprocal here. So it is coming out as 0.084 F. 0.084 F, which is feed, which is same. And for tool 2, H2 is coming out as 30 10 plus 1 divided by 7 10, and we will take reciprocal here. So 0.114, so point F. So this is your H2's value. So H1, H1 is less than H2, therefore better surface finish for tool 1. So tool 1 will have better surface finish because roughness value for the first tool is less, therefore tool 1 will have better surface finish than tool 2. And here we can know this also, that we have used this F by tan side cutting edge angle plus cot end cutting edge angle to calculate the surface roughness, because the radius of nose is 0, and therefore we don't use the formula F square by 8R, which is used when some value of nose radius is given. And our final answer here will be H1 is 0.084 F. F is same, so it will be taken in both the H as F only, and it is H2 as 0.114 F for the tool 2. So H1 is less than H2, so better surface finish for tool 1. So easy questions. It might come in GATE examination. It has come in GATE examination, but for the conventional but as a conventional question, and very long time ago, so it might get repeated. It might get asked after providing you the other than ASA, we have also ORS. So that ORS format, the tool specification might be given in that format, and you can get asked the same question, or you can get asked about the better surface, not better surface finish. You can get asked about the values of the ratio of the values of surface finish, or ratios of the values of roughness. So this is very important for you to understand that there are two formulas of surface roughness, and there are two specification formats, ASA and ORS, and both of these things you have to know, you have to properly remember to solve this question properly. So let us just discuss about ORS also. So first let us write ASA here also. So ASA tool specification is given by this: alpha B is first, alpha S is second. So alpha B is back rake angle, side rake angle, then we have relief angle. Again, relief angle has end relief angle first, then side. So side is coming second. So this is general pattern that it is following. CE is the end cutting edge angle, and again CS side cutting edge angle, and R is the nose radius. So side is coming in second. So remember this so that you can easily just know the formula, know the specification format. And we have rake, relief, then cutting edge in this way, and we have side coming in second in a set. And at last we have this nose radius. And for ORS, which is orthogonal rake system, we have our first term as I, which is angle of inclination, then orthogonal rake angle, then gamma side relief angle, gamma 1 end relief angle. So here end is coming last and side is coming first for this, but here again we have end cutting edge angle and now approach angle lambda, and at last we have nose radius in millimeters. So this is approach angle. And what is the value of approach angle for orthogonal turning or orthogonal machining? It is 90 degree or principal cutting edge angle. And let us also discuss this orthogonal cutting and oblique cutting inclination angle. So for orthogonal cutting, I is equal to 0, and for oblique cutting, I is not equal to 0. So always remember this things that I have shown in the screen. These are very important things to remember that you should not be forgetting. You should be revising it time after time, because direct from this questions might get asked. For example, in the question that we have just seen, it was given to the tool specifications in ASA format was given for two tools, and we have to use the side cutting edge angle and the end cutting edge angle there, which are clearly in the second to last and the third to last positions. And there is also written the easy way or a trick to remember this format for ASA, which is rake angles come first, relief angle then comes after that, and after that cutting edge angle comes, and at the last of both the formats we have nose radius. So remember, last we have nose radius, and in the ASA format the first term is not side angle, the second term is the side angle. So in a set of, or in a rake angle terms, the rake angle comes one after another, relief angle comes one after another, cutting edge angle comes one after another. So the second rake angle will be the side, the second relief angle will be the side one, and the second cutting edge angle will also be the side one. So remember, side coming in second in a set, or side comes in a second in a set. And ORS is a system is also shown here, ORS system specification format. Here the first term is the inclination angle, and for orthogonal cutting, inclination angle is equal to 0. For oblique cutting, it is not equal to 0. You can just remember this from the name itself. Oblique is inclined. Generally oblique means inclined, or it means inclined, not generally. And orthogonal is 90 degrees, so I is equal to 0 for that. And alpha is orthogonal rake angle, gamma first is side relief angle, gamma 1 is end relief angle, CE is side cutting edge angle as discussed in the ASA format, lambda is approach angle or principal cutting edge angle, which for orthogonal cutting angle is equal to 90 degrees, and R is the nose radius in mm. And also that the thing we have discussed before is lambda plus CS is equal to 90 degrees, so you can remember this also, which is valid here. So side cutting edge angle plus lambda is 90 degrees. So if you have been provided this lambda, for example 60 degrees, then you can find the side cutting edge angle here by subtracting 90 minus 60, by doing the 90 minus 60 calculation. So it will come out as 30 degree. So side cutting edge angle is also can be calculated if we are provided ORS system. We just have to do a lambda plus CS is equal to 90 degree, use this equation and use the lambda value from the ORS specification, and we can get CS, that is side cutting edge. So I hope the class has resumed. So yes, it is resumed. So let's do our final question of the day, and then just end the class. So final question is from topic which is metrology's part, and here it is asking us, the question is giving us this diagram, this geometry, and is asking us first of all for a relation between these three terms that are shown here, and secondly we are being asked about the last sentence. In the last section we are being asked that if a unit increase in D has to result in a unit increase in H, what must be the angle alpha? So if this geometry, this figure right here, if we increase a unit value of H and therefore a unit value of D also increases, so then what will be the alpha here for this figure? So first of all, we have to write down the equation relating the dimension H with the diameter D and the angle alpha. So this type of question has been asked in one of the GATE examination, I think recently in 2020 only. And you have to remember that if you are doing this type of question, then if options are given, then use the options and solve the answer, because that will be the one of the fastest approach for you to do. So if possible, and if you can get the answer by that, then use the options, because using the options and getting the answer is absolutely fine. And even you can say this thing is one of the better things for to do, one of the clever things for to do, because you are not wasting your time by doing lengthy calculations and lengthy derivations, and therefore if possible you have to use the options and get the answer. If you can save time and do that correctly by just calculating that risks involved in them are not that much, and if you can check the answer, then that is fine also. So here what we will do here is we will draw a triangle, right angle triangle, and then we will find the relation among HD and alpha by using that. So let's bisect this, and if we draw a 90-degree perpendicular here, then this angle will be alpha by 2, and this right here, if it is O, let's do that with a little bit more precision. So this is center, let's take it as C. Let's just write it as C, this as A, this as B. So in triangle A, B, C, what we are seeing is that sine of alpha by 2 is equal to, what will be the length of BC? It will be D by 2, and what will be the hypotenuse here? That is AC. So it is nothing but H plus D by 2. So H plus D by 2, and what we have done here is we have done BC divided by AC. So sine alpha by 2, let us just write this by simplifying. It will be D divided by D plus twice of H. So this is the relation between the three terms that are given in the question, and this is the answer. So now what it is saying is that if D becomes D plus 1 and H becomes H plus 1, then what will be the value of alpha? So this, if D becomes D plus 1 and H becomes H plus 1, just understand what the question is saying here. The question is saying the figure must be followed in the second part also. The figure must be followed for after the changes also. So if this figure is valid for the terms that are changed or after the changes have been made, then what will be the value of alpha? So this equation will be followed even for this D plus 1 and H plus 1. So if D becomes from 10, 11 and if H becomes from 2, 3, then what will be the value of alpha then? So we will use this equation then also, and there sine alpha by 2 will become D plus 1 divided by D plus 1 plus twice of H plus 1. So from here we will say that sine alpha by 2 becomes D plus 1 divided by D plus twice of H plus 3. But this sine alpha is also equal to this D divided by D plus 2H, which was for the first set of parameters or which was before the changes being made. So we will just simply put this as d by d plus 2h and d plus 1 divided by d plus 2h divided by plus 3. So from here we can get a relation between d and h. So dh and h are related for the second part assumption, or the second part changes. As what we will do is we will simply find it here. So let's do that calculation in a page here. So d divided by d plus 2h plus 3 is equal to d divided by d plus 2h. So from here it is d plus 1. So from here let's multiply d plus 1 with d plus 2h and multiply this d with d plus 2h plus 3. So d square plus 2hd plus 3d, and it will become d square plus 2hd plus d plus 2h is equal to this upper term or upper values, upper term sum. So this will simply get cancelled out and we are going to left with twice of d is equal to twice of h. Therefore d becomes equal to h if the second part is to be followed, that is a unit change in d. If it results in a unit change in h, then if this geometry is to be followed, then what will happen is d will become to h, equal to h. So after this, what we will do, we will just find alpha by putting, we will find alpha just by putting d and h equal. So d becomes h, so this will become d divided by 3d. So 1 by 3, sine inverse of 1 by 3 will be this much, but it is into 2. So the sine angle becomes 38.94. Sorry, the alpha angle becomes 38.94. So alpha I'm writing at the top, it is becoming 38.94 degrees. And we have calculated that after using the relation which we have obtained. So alpha is now coming out, the final answer is coming out as 38.94, which I have written at the top here. Below the manufacturing, I have written manufacturing word, I have written this alpha is equal to 38.94, which was asked in the question. So again, this type of question is asked in just recent GATE examination of this year, and this can get asked again, because again this is aptitude type question and GATE exam contains the word aptitude, so you can just expect aptitude type questions to come. And this question came in previously in GATE conventional paper. Again, there is chance that this might get repeated, or this type of question get come. So to find the relation, you have to first see how, if you can do triangles, if you can do draw triangles or some square, so that you can get those three related by each other. So triangle is for relation between the three terms, and we find out that relation. First part of the question was that, and the second part we just the second part was not structured or phrased better. The second part meant that if d was increased by a unit and h was also increased by a unit, then this figure still holds true. Then what will be the value of alpha? So if this still holds true, then sine alpha by 2, which was equal to d by d plus 2h, will also becomes sine alpha by 2 equal to d plus 1 divided by d plus 1 plus twice of h plus 1. So this both we put them equal, and we found out the relation between them. If the unit increase in d resulted in unit increase in h, and this figures hold true, then d becomes equal to h, and we just put that in the first equation, that first in the relation between hd and alpha that we found out in the first part of the question. And after doing that, we got the answer as alpha, that is the angle shown in the figure, is equal to 38.94. We calculated alpha by 2 and then we multiplied 2 to get the final answer, that is alpha is equal to 38.94 degrees. So that's it for today's class. we just discussed a lot of topics here. A lot of conventional questions were discussed here, were done here, and we just mainly in this class we found that lengthy questions, which is the pattern that the recent gate exams has been following, might which is being asked in the recent papers, might get asked again. So you don't have to just panic, you just have to be calm and do the question according to the basics that you have learned. And just remember the formulas that I have told you to remember in this class, and just write it down in your copies and things like that. So that's it for today's class. Thank you for watching. Best of luck for your preparation. And here is the code, 10% off code that you can use to get 10% off. ABHIMI is the code. And just go to the Unacademy's website, use the code there to get 10% off. And you can also use this code, and this code can also be used by multiple students, multiple accounts. So that is also one thing that you can remember, and to share this code with other students. So if you found the concepts taught in today's class engaging and beneficial, and just you found this class worth your time, worth spending in your time, the time spent is worth it, if you found that, then just hit the like button, subscribe to this channel, hit the notification icon or bell icon to get the notifications. Join our Telegram group for the latest updates on our upcoming videos. And thank you for watching. Best of luck for your preparation. Stay safe and take care. So that's it for this class.